This video is on exercise 1, which is on page 32 for lesson 22 out of the grade 8 module 4 book. So exercise 1 talks about Peter paints a wall at a constant rate of 2 square feet per minute. Assume he paints an area y in square feet after x minutes. So first thing we want to talk about, which is kind of the common theme in this whole lesson, is constant rates. So this phrase, constant rates, means that there's going to be two variables for this explanation. Let's use x and y. That doesn't always have to be x and y. It could be just any two variables given, but we're going to use x and y, especially since we're going to be using coordinate grids. And those two variables have a relationship that y jumps the same amount every time x changes by 1. So it's not that y is going to go up by 1 each time. It's that every time x changes by 1, so goes up by 1 or down by 1, y is going to move the same amount. Not by 1, y might jump by 3, it might go down by 4. It's just that every time x goes up by 1, y is going to make the same jump as it did the previous time x changed by 1. So let's kind of look into some examples or exercises into what a constant rate looks like. So in this case, the constant rate is that every time the minute goes up by 1, so remember this means per 1 minute, 2 square feet will go up, or y will go up by 2 square feet. So we want to express this situation as a linear equation in two variables. So we know every equation has an equal sign. And then on each side of our equal sign, I'll show you how to kind of set up and think this through. So we are going to put a fraction bar. And the reason I put a fraction bar here is because we have the word per. So per minute means that whenever I have a relationship like this is a proportional relationship where I have as one thing changes, the other thing changes. So let's see, on top we're going to have square feet. On the bottom I'm going to put minutes. And whatever's on one side I'll put on the other. So let's see, I'm going to have, well, we'll have square feet here, minutes down here. On this side, let's use the numbers they actually give us. So they give us 2 square feet per minute. That means per 1 minute. Now, we don't always want to just we don't want to always just go up by ones each time. That would take forever if they gave us 120 minutes. So we want to come up with variables so that we can easily just plug in a number and come up with how many square feet that would result in. So let's use the equation, let's see, y for square feet and x for minutes. That way we can put in any number for x and use an equation to come up with how many square feet that gives us, which is y. So for our equation, we want to set it up so it doesn't take as much work to get to that answer of how many square feet were painted. Meaning that let's set this up so that we have just y by itself. So to get y by itself, we're going to have to move that x. So there we go, we have times x minutes. Whatever I do to one side, I have to do the other. So we'll have times x minutes here. The whole reason I did that is so that that would cancel out. So we would have just y left on this side, y square feet. And over here we have x times 2 over 1. Well, that simplifies to x times 2 over 1. 2 over 1 is just 2. So to clean this equation up, I like to have y equals, because that's what every linear equation looks like. And then x times 2 is written as 2x. That's the shortest, cleanest way to write it. So there we go. We have our linear equation. So now let's do part B where it says sketch the graph of the linear equation. So we want to use those tricks from the previous lesson using slope and y-intercept so that we can easily sketch this up. You could also make a table of x and y values, but that takes a little more work. So I'm going to remind you that the equation of every line is y equals mx plus b, where m is the slope and b is the y value of the y-intercept. So let's kind of use the equation that we came up with with the last one there. So the equation, we have y equals 2x. So let's kind of use this y equals mx plus b to figure out what we have in the equation we came up with. So this 2, it's the coefficient of x. It's attached to x. That means the slope of this problem is 2. So our slope is, remember, m stands for slope. M is equal to rise over run. So in this case, m equals 2. Well, we can make 2 a fraction by putting it over 1. So we have our slope. We know how to get from one point to the other, but what is a starting point? Well, a starting point in this case is going to be the y-intercept. So remember, the y-intercept is the y value of wherever the line crosses the x-axis. So the problem in this is we don't have a constant being added. So it's just we're looking for plus a number or minus a number. We don't have that in this equation. But as long as you remember that adding zero doesn't change the value of any equation. So when you don't have anything being added or subtracted, remember you have plus 0. So our y-intercept is 0, 0 in this case. So we'll go down here and we have our starting point now, 0, 0, which is right here. And then I'll use my slope. So my slope is up 2 over 1. So up 2, oh, and look at this. We see how this graph is counting by 2. So really, I'm just going to go up one grid line because each grid line counts for 2. And then over 1. Ooh, that's a little tricky here. Actually, no, it's not because the x-axis is going by 1. So up 2 over 1 tells me my next point will be right there. And as long as I have 2 points, I can just use my ruler and draw a line through those points. So there we go. I took my ruler, I made sure I went through both points. Now I'm just going to finish this up by putting an arrow just on this end because we're measuring time in minutes here. We can't continue going this way because you'd have negative minutes and that's just not a realistic thing. And I'm going to make sure I label it with my equation. So y equals 2x. All right, there we go. So we sketched the graph of the linear equation. So go down to part C. It says, using the graph or the equation, determine the total area he paints after 8 minutes, after 1.5 hours, and after 2 hours. And it's just reminding us that the units are in minutes and hours. So let's do the total area he painted after 8 minutes. So we'll say after 8 minutes. We won't need much space for this. So remember, X stands for minutes. So 8 minutes, we just look right here. We can see right here is the 8-minute mark on the graph and gives us 16 square feet. So easy enough. So after 8 minutes, he paints 16 square feet. All right, let's talk about after 1.5 hours. So after 1.5 hours, here's the tricky part, is that now, remember our graph is time measured in minutes. So when they give us hours, well, that doesn't work using our graph because we're measuring in minutes. We don't have that unit. So we have to take hours and we have to convert it to minutes. Here's what you want to do for this. So after 1.5 hours, we want to remember that 1 hour is equal to 60 minutes. So 1 hour equals 60 minutes. That's always true. So we're going to say equals. We're going to keep hours up here. We're going to keep minutes down here. Now instead of 1 hour, let's talk about 1.5 hours. So 1.5 hours. I'm going to put that in parentheses just to remind you that when you're using your calculator, you can do all that using that A, B/C button. Just make sure you put it in parentheses. And we don't know the number of minutes, so I'll put X minutes, and that makes sense because X is the axis that our minutes was on in our graph. All right, so now to solve this through, we can kind of do what we did over there. Multiply by X, multiply by X. This cancels out on this side. And we'll just keep going here. X times, now this is going to be 1/60 equals 1.5. That's what's left over here. And even though this kind of goes all around, I'm just trying to find out what X is in this case. So I will divide by 1/60 on both sides. So X equals, say, 1.5 divided by 1/60. You'll get 90 minutes. So, oops, here we are, 90. So X stands for minutes. So 1.5 hours equals 90 minutes. So after 1.5 hours, let's keep going with this. This is where I want to use the equation. The equation I came up with bring it back up here. The equation we came up with was y equals 2x, where y stands for the area in square feet and x stands for the number of minutes. So now that we have x equals 90 minutes, we can just use our equation. Y equals 2x. So in this case, it'll be y equals 2 times 90. So y will equal 180. So after 1.5 hours, he paints 180 square feet. So there we go. Here we answered one of them. Here we answered another. Okay. And let's see, after 2 hours. So after 2 hours. So we got to do the same thing though. To use this equation, we have to get x in minutes. We can't put 2 in because it's not 2 minutes, 2 hours. So we do the same thing here. We don't necessarily have to rewrite it. Just remember that for this, instead of 1.5, right here, we would have a 2. So x times 160, or I'm sorry, 1 over 60 will have x times 1 over 60, it would be x equals, instead of 1 1/2 hours, we would put 2 right here. So you would just end up dividing 2 by 1 over 60. And you would have x equals 120 minutes. And then you just use your formula. So y equals 2x, y equals 2 times 120. So after 120 minutes, he would have painted 240 square feet. So after 2 hours, he paints 240 square